Okay, so in this lesson we're going to be solving trigonometric equations, and in section 8.1 we did them graphically, and so in this section we're going to use algebra with the inverse trig functions and identities to solve trigonometric equations. So if you remember, in section 8.1 we solved equations like the ones you see here, and those are called basic equations, and we're going to talk about how to do that algebraically in this lesson. So we're going to look at this first one here. It says solve cosine of x equals 0.6. So what we're going to do then is we're actually going to solve then the inverse cosine of 0.6 equals some number, and that's how we're going to solve this. And you need to think about the fact that on our unit circle that there are actually two places where cosine is positive, and so we have to take those into consideration. So when we find the answer for this, we're actually going to be looking at, if we get an answer in the first quadrant, that'll be theta, because we're trying to find out when this is equal to theta. In the second quadrant, we will do, because this angle here is pi, and in the second quadrant would be pi minus theta. If it's in the third quadrant, it would be pi plus theta. And in the fourth quadrant, we can either say that it's negative theta, or we can say it's 2 pi minus theta, depending on what the requirement is for their answer. And so we're going to have these triangles that in the first quadrant will look like this. Second quadrant, it's here. Third quadrant, it's here. And this is something that we've talked about before in the fourth quadrant here, where all of these angles, the angles here, are our reference angles theta. And so in the second quadrant, we didn't quite make it to pi. In the third quadrant, we're a little bit more than pi. And in the fourth quadrant, we're a little less than 2 pi, or negative angle. So what we want to do is we want to take our calculator then, and we're going to find out when does cosine equal 0.6. So first of all, make sure your mode is in radians, and ours is. And so then we're going to do the inverse cosine of 0.6, and we get 0.93, and we'll use 2 decimal places right here. So we'll say then that theta is equal to, or x, I guess I was using the wrong letter here, so that's alright. We'll get rid of the theta. And that this equals x, so then x equals 0.93. And since cosine is positive here, cosine is positive in the fourth quadrant also, because that's where x is positive, then we would say that it's either equal to 0.93, or x could be equal to negative 0.93. And then we're talking about all the solutions here, so we have to add 2 pi n to both of those numbers, and say where n is an integer. That'll be our first example then. And let's look at the next one. Okay, we're going to do the same thing. So we're going to do a little work here, and let's take and group this thing up so we can utilize it. Alright, so then for the second one, example here, we want to find out when does sine equal negative 0.75. So what we're going to do is we're going to solve the equation then, the inverse sine of negative 0.75. We want to know when does that equal x. So once again, we'll go to our calculator, and we'll do the inverse sine of now we're just going to do the positive angle here. Do inverse sine of 0.75 and find the answer to that. And what this is going to do is this is going to give us our reference angle. So we're going to say this is 0.85. So we're going to say that theta here equals 0.85. And that's our reference angle. Now, we need to think about when is sine negative. And since sine is our y values, that's going to be in the third quadrant and in the fourth quadrant. And so our answers here are going to be x is equal to, so in the third quadrant, we're going to take pi and add our reference angle theta, so pi plus 0.85. And then the fourth quadrant, we're going to just say that it's just negative 0.85. And then, so we can do that math there. So if I do pi plus 0.85, we get 3.99. So this is equal to 3.99 plus 2 pi n. And then we just have plus 2 pi n here. And then we say where n is an integer. Alright, so so what I'm doing is I'm always going to use the positive angle when I find this value. And so that gives me a reference angle, and I can use that reference angle then as my theta for whichever quadrant I'm in. So in this case with sine, we were in the second or the third and fourth quadrants. So we took pi plus our reference angle and then just the negative reference angle. All right, so let's look at this last example 3 here with tangent. And so once again, we're going to do the same thing. We want to find out where inverse tangent of 3 is equal to x. So here it says tangent is positive. And if you remember, though, tangent has a period of pi, so we really only need to find one answer. So we'll go ahead and use our calculator here and do inverse tangent of 3. And that gives us 1.25. And so our answer here is going to be that x equals 1.25. And I'm going to say plus pi n in this case instead of 2 pi, because the period for tangent is just pi. And then once again we'll have to say where, something like me. So where n is an integer. And once again, the reason we only need one is that if we look up here at our triangle, if we look at tangent here in the first quadrant, and tangent is positive also over here in the third quadrant, but all this is pi plus theta, and so that would just give us the same answer. So for tangent, then we can just do plus pi n. So to continue with our solving these equations, when you have a little more difficult equations like this one here, 8 cosine of x minus 1 equals 0, the first thing you have to do is solve for cosine. So as any other equation that we would solve, we want to get the whatever is being added or subtracted, we want to move that to the other side first and then divide. So we're going to add 1 to both sides first. And then divide by 8. So we get the cosine of x equals 1/8. So then we're going to go to our calculator again, and we will do inverse cosine then of 1/8. And so we get 1.45 for the value of x. And then we think about when is cosine positive, and that's in the first quadrant and the fourth quadrant again. So we will say that x equals, in this case we can do plus or minus 1.45 plus 2 pi n, and then where n is an integer. Right? And then our next example here. Here we're going to use our basic equations, but we're looking at a situation where we have a number that's on unit circle, like square root of 2 over 2. So we want to find out when does sine of u equal square root of 2 over 2. And so if you're looking at your unit circle, that we will know that sine is positive once again in the first and the second quadrants. And so here we'll say that u is equal to, in the first quadrant, pi over 4. And in the second quadrant, 3 pi over 4. And then both of them, once again, will be plus 2 pi n. And in every one of these problems, we have to say where n is an integer. Now for this last example we have for this lesson, we're going to solve it the same way we did with the last one. Here it says that sine of 2x equals square root of 2 over 2. And we still have, since when does sine equal square root of 2 over 2? So we're looking at those values. So, but instead of just saying x is equal to that, we're going to say that 2x equals pi over 4 plus 2 pi n. And that 2x equals 3 pi over 4 plus 2 pi n. Now the difference here is then, since there's a 2 here and the 2 here, so since it's 2x, that because the period then is decreased, so it's only half, then that means that it's going to change our values too. So what we've got to do is we have to actually divide everything on both sides then by 2, because we want to know what x equals, not what 2x equals. So here we're going to get x equals, when we take pi over 4, divide that by 2, we get pi over 8. And then it's plus pi n. And then our second answer will be 3 pi over 8 plus pi n. And then where n is an integer. So the one thing you have to make sure of with these problems, that if I have 2x here, or 3x, or 4x, then I'm going to say that it's whatever it is, 2x, 3x, or 4x is equal to my answer, and then we have to divide by that number to get the correct answer for them.